Hello everyone, I'm Mohammed Taha, and today I'm going to be talking about the negative externalities of typosquatting. So this work was primarily done at UIC with Jiang, our collaborator at RSA, Joe, and my advisor, Chris Kanich. So speaking of cybercrime in general, the main focus is on the detection and removal of malicious bugs in software and code. Meanwhile, other research aspects of cybersecurity also focus on the economic analysis to investigate the success of cybercriminals. But the real question is that, why is this important? Well, the ultimate goal behind is to provide convenience to users and minimize the harm caused by these kinds of breaches. Now, it is essential to realize that harm is not just monetary, but can also take the form of wasted effort and a loss of users' time. Like other cybercrimes, one of the common forms of cybercrimes is typosquatting. The attacker model works in such a way that individuals with malicious intent register domains that are similar to established websites and are most likely to be typoed by users. And the next step is that they host either advertisements, malware, or even sometimes competing content on the following websites. Now let's look at an example here of how typosquatting causes a loss of users' time and effort. Now Bob here accidentally mistypes youtube.com and gets malware on his system. Now he's probably going to get a free license for his malware antivirus from his company, but he'll probably need to spend a lot amount of time and effort using that, removing the antivirus. Now, however, previous studies have shown that malware delivery is pretty rare with typosquatting sites. But there is still another aspect of harm that this cybercrime entails. Let's look at an example here to evaluate on this. Now, Bob here wants to go to facebook.com. He accidentally mistypes and he reaches at faecbook.com. Now, what does he do? He sees an error page. He realizes he made a mistake. He corrects his mistake, and now he's on Facebook. Now let's consider the case. I'm sorry about that. Yeah. So now let's consider the case when instead of arriving at facebook.com and seeing an error page, Bob saw something that looked like this. Now, if he does not have enough internet education, he's probably going to fall for this phishing site, and he's going to see that this is a survey, he's going to fill it out, and in that case we're going to consider that this is a user loss for facebook.com. However, if he does realize that this is a phishing site and he does eventually go to facebook.com, there's an extra amount of time consumed in this whole process. So we define the delta T here as the difference between the additional time consumed as a result of typosquatting and mistyping as initially the time that is lost due to typosquatting itself. And the fact that a request to faecbook.com followed by facebook.com allows us to infer intent that user wanted to visit facebook.com within the initial visit that we use as our user intent model. Now these are some of the motivations that help us study typosquatting. We know that typosquatting is big because we see like a lot of these organizations invest into defensive registrations, and these brand protection websites such as Mark Monitor have an active presence. Apart from that, it's also natural for users to keep on making typos, and this motivates these typosquatters to gain from this. Typosquatting is also feasible to study because it's observable within passive network data, and because we can see a visit to a cybercriminal website followed by the legitimate website within the passive data, this essentially allows us to infer intent and see how much time it took the user to actually get to the intended destination website. Our work focuses on three main aspects. First, we define a conditional probability model to passively detect typosquatting domains. Next, we present a harm quantification metric to evaluate the loss of users and their browsing time. And eventually, we apply this harm metric to quantify the cybercrime of typosquatting itself. Now, traditional analysis of harm look at these kinds of harm analysis on a more broader scale, whereas our work is a more open methodology with more fine-grained measurements. Let's look at the data sets to develop some context. So we have three main passive data sources that included HTTP data logs from a university network, DNS logs between the recursive resolver and the internet from that same network, and proxy data from an enterprise solution. For active sources, we use a high fidelity crawler to observe redirects for all the prospective typo domains, and this is one of our active forms of data collection during this research. So by looking at these data sets, our main goal is to extract typo pairs by evaluating user intent. We do this essentially by leveraging on the user's continued intention to visit the actual destination website even after he has been a victim to typosquatting. Now, this intention can be fulfilled in many ways. We refer to them as discovery methods. So some of the discovery methods includes searching for the target domain, correcting a URL mistake in the URL bar, or either going to it through other sources that might include clicking on ads or browsing it on hyperlink. So we can use our intuition to quantify user intent by using the conditional probability model. We apply this conditional probability model to all possible discovery methods that I previously discussed. Now, looking at the domain pairs, we look at all domain pairs that have an edit distance of 1 and exist within 33 seconds of each other. Furthermore, we also ensure that all domains that are second in the pair are resolvable, and the pairs applied at least 3 times within the data set. Now, having all the candidate pairs, we apply this probability model where D1 here is the prospective typo domain. The graph here shows that the manually evaluated accuracies for each probability bin. And we set our threshold cutoff at 0.2 because we see a distinct fall in accuracy. Now let me go ahead and explain how our conditional probability model is different from simple lexical analysis. By looking at these examples, we see that EBA.com followed by eBay.com appears 90% of the time within the data set. However, NHL and NFL, which might seem to be lexically similar websites, only appear 0.08 times within the data sets within the same 3-second window. Sorry about that. So having all these typo pairs, the next step was to perform characterization on them. So we defined 3 main categories. The first one is for adversarial registrations, that include park domains, domains that have malicious content, or domains that are hosting any other material that are not related to the target website. The next category is cooperative registrations. These include redirections as well as defensive registrations, and these domains are essentially somehow linked to the intended website that the user wants to visit. And the third category is for unregistered domains that do not resolve to a valid domain name. Now what next? Now we have the idea of how we extracted all the typo pairs and their respective categories. Our main concern is to evaluate the harm caused by each type of category. Now in this next section, I will cover some of the main findings of our work, whereas more fine-grained details are available in the paper. Now looking at the harm here, we see that the average delay for adversarial and unregistered websites is pretty much in comparable range. Whereas cooperative registrations have a lower delay than adversarial unregistered, which is intuitive. And similarly, for the average loss rate, we see that though adversarial registrations do have a higher loss rate of 16.8 in comparison with the unregistered domains that only have a loss rate of 11, they're pretty much still in comparable range. Another interesting phenomenon to note here is that some of the cooperative registrations have a higher delay than a natural redirection would have. Now, a reason behind this is a specific kind of defensive registration. This example elaborates this. Now, this domain typo is apparently registered by yahoo.com, but instead Yahoo did not decide to run a JavaScript or a 3xx based redirection. They decided to show this error message that includes the Yahoo homepage link. Now, a user encountering this is pretty much similar to if he had encountered a website that had domains on it parked with ads or an unregistered website, which explains the added delay. We also observe that different discovery methods have varying delay trends. For adversarial domains, we see that the typing delays are essentially lower than the search delays, which is intuitive to understand because it's more likely a user is going to correct his mistake in the URL bar rather than searching for the intended domain. However, for unregistered domains, we see that this is an anomaly, that the search delays are actually lower than typing delays. Well, a reason behind this is a characteristic of modern browsers. Now, modern browsers have the capability of performing pre-resolution. Now, once they do that, while a user is typing the domain, if the domain resolves to an NX domain, the browsers treat the string itself as a search query, where the domain in itself, and on hitting enter, the user is redirected to the search page, where the domain is essentially, the target domain is essentially just one click away. We also see that specific categories of the typo domains, and we see that the popularity exists within the long tail of distribution. This also corroborates with some of our previous work, and we see that after normalizing the number of typo visits, the most websites that were typoed were essentially adult and blog websites. Now, this graph here shows the target domain distribution. We see that the domain that was typoed the most was not a search engine, but essentially it was a ratemyprofessors.com. Now, essentially this is a university data set, so it's skewed, but essentially it means that if you're a professor in the audience, you want to make sure that you have a good rating, because we have evidence that students do visit this a lot. We also perform delay and success clustering on the target domains, on the typo domains with their respective DNS providers. And we see that for delay clustering, we see that certain amount of DNS providers are actually helping users to get to their intended domain faster because they have a lower delay than the average unregistered typo delay. We also see similar trends for success clustering, where some of the DNS providers actually have lower loss rates than an unregistered domain loss rate that was evaluated from the data set. Looking at the top DNS providers, we see that they're pretty much similar to those providers that also provide domain parking services. Now, this is an unsurprising result because mainly the monetization and advertisement techniques within typosquatting are pretty much similar to domain parking. Now, looking at the loss of revenue, we need to convert to form a basis of comparison. We essentially need to convert the negative externalities of lost users and loss of time into actual dollar amount. Now, we do this so let me explain negative externality because it's an economic term. So in our context, negative externality here essentially means that the loss incurred to the site owner as well as the users who intended to go to the website opposed to the gains of the typosquatter. So looking at the intended site owner has a negative externality ratio of 18:1 against the typosquatter. Now essentially in other words, this means that on a $1 gain by the typosquatter, the site owner lost $18 of revenue. Now it's also important to consider the loss of users that are browsing the websites. And by using per capita income and the average delay times, we boil down to a number of 29 cents that is lost due to typosquatting per year. We also evaluate the defender ratio that comes out to be 4.62:1, which is far lower than the negative externality ratio of nonviolent crimes. Now, in conclusion, I would like to say that typosquatting is much less socially damaging because it has low negative externality ratio in comparison to other forms of cybercrime that include spam and phishing. And defensive registrations we see in the data set that do provide users get faster to their website, but that is essentially a consequence of the users mistyping rather than typosquatting. And because the delays between the mistyped domains and adversarial domains are not significantly different, well, we can pretty much say that typosquatting is here to stay, and it's unlikely that a technical or policy intervention will substantially increase the quality of life of the users that are browsing, unless that intervention also takes care of users' act of mistyping as well as typosquatting. So thank you very much, and I'll take questions.
Thank you for a very interesting talk. Any questions?
I've been asking this question for decades. Why does anybody type in a URL?
Sorry?
Why in the world does anybody type a URL? That's got to be really unusual user action.
I didn't quite get the question.
Typing a URL into the address bar
Yeah.
is a very inefficient way of conveying that information. Almost always you're referred from somewhere else, or you're prompted by your browser history. So how often do people actually have to type in a URL?
Also, well, I would like answer this question that whenever you want to go to a website, you actually go into the URL bar and type it. I mean, that's how I go to the website. I don't usually go to Google and search for it. And
Any other questions?
Sumun Kaist. Typosquatting or similar URLs. So phishing is a major problem in Korea. And like government sites, sqo.go.kr is a government site for public prosecutor's office, and phishing, phone call phishing.
Right.
They use sqo.com, and people I know. So have you looked at these URL similarities? It's not typosquatting, but similar, but used by phishing. And in Korea, if you call a hotline, they actually, I think they do something with the DNS registration and block the access to the suspected phishing site. So there is much room for policy intervention to help victims.
yeah, I would definitely agree with that, and I would say that this would be like one form of future work that could be done, that looking at that specific kind of specialized form of phishing in which you mentioned for Korea. I mean, this data set was like really based on a US university, so our results do not reflect anything that happens elsewhere in the world. Thank you.
Hi, Cami Vanier, Indiana University. This is mildly a follow-up, I guess, on the prior question, but I'm curious how much you know the source of the typo error, like whether they were clicking on a link, whether you're actually looking potentially at bit rot, because we do see some problems sometimes with with letters being switched by the computer itself in route. Did you grab any refer type information or any other information from the HTTPS stream that would, or HTTP stream that would allow you to determine whether this is something human typed, or if it was a link, or if it was anything else?
All right, so for the data set, we were looking at all the root loads that the user entered. So these also included some refers, and like the actual numbers are present within the paper, and due to time restrictions, we have these specific categories that how many users appear to the typo by typing in or searching it, and following other various methods of reaching the target domain. But like, if I understood the question correctly, that the details are present in the paper.
Okay, thank you.
We have time for one more quick question.
Thank you. Amir Ramati, University of Michigan. There are various add-ons that browsers have that go and autocorrect some of the common typos, such as eBay or EB, or like for YouTube. Have you looked at the effect of those add-ons on how much they're effective against these attacks?
Well, I actually haven't looked at them, but I'm concerned about the add-ons, like the example I mentioned, that NHL and NFL. Like, how do these add-ons differentiate between if this is a legit typo, or are these two similar websites lexically similar websites that just appear to be directly unrelated. So like how would that add on?
I think they typically look at like the most, like the top 100 or 1,000 websites. And
Right.
if what you've typed in is within like some distance of that website's name, they will brought up a alert sign that said like, are you sure this is the website you wanted to go, or is this the actual website?
I mean, isn't that more time consuming? We haven't like considered these add-ons, but it would be interesting to see that, okay, do these add-ons that they provide users with a list of possible websites, it's pretty much like searching a thing, they type in and the add-on pops up, and I haven't used them, but if that's what they do, they pop up and like give a list to the users, it's pretty much like going to Google and typing in the domain and then
More
clicking
of
on the
giving a
search.
list, they just, if it's just like one character difference from a major website, they just bring up a sign and say like, this is what you typed, are you sure you don't want to go, for example, to YouTube instead of tape or something else?
Well,
Anyway,
I mean,
just interested to
that
look
would,
at
that
it.
would be a
Thanks.
valid example, but like there might be some false positives within this add-on because like, again, I'm being redundant, but like NHL and NFL are both popular websites, and the reason I'm referring them is that they were present in the data set. And I wouldn't know like how would that add-on treat these two websites.
Okay, thank you.
Thank you very much.
Let's thank the speaker again.